Welcome to this video which discusses the second assignment, the Part B assignment for Module 2. This primarily covers the lecture notebook content seen in the Part B and Part C lecture notebooks for Module 2. This involves numpy and array manipulation. I'm saying the expected time to completion is around 6 hours. It is the only thing you have to do for this week of the class in the semester. So I want you to do a lot of experimentation and give you plenty of time to play around with it. So that's why I think if you were to really dive into it, you might take 6 to 9 hours just by trying different things and making your own problems and examples on top of what I'm showing. Much of this assignment makes use of the following arrays. Some problems will also involve creating new arrays as well. First, we're going to import numpy as np as is standard. I'm going to create two different constants, 1 and 2.0. I create the following arrays, 1 through 5. And notice that there's no output generated. I suggest that you look at this following documentation involving routines. This is array manipulation routines. I actually have an older release, so I will change the documentation to the more stable release at time of submitting this onto Canvas. Now, you should always inspect the data. So all of this is a preamble before the actual problems start. So here, if you just look at the shapes of these arrays I've created an array of a one-dimensional array of shape 3, nothing. That's array 1. Array 2 is 3, 1. So it's a two-dimensional array. So it's got 3 rows, 1 column. Array 3 is a two-dimensional array of shape 2, 3. So it's got 2 rows and 3 columns. Array 4 is a three-dimensional array, and it has one 3x2 array inside of it. And array 5 has 3 2x1 arrays. That's a good way to think about arrays 4 and 5. And you might want to add comments to describe these shapes and interpret them here. I highly recommend that either as code comments or as a markdown cell, to create a markdown cell here for you to edit. That may be something that you want to do. Now, problem 1. Array shapes, trying addition, and broadcasting. Problem 1a. You need to try running each of the following individual code cells and answer the following 2 questions in the markdown cell below that follows. So here's the markdown cell that follows. So you need to answer the following questions after trying to run these. And you should be able to answer them actually from the lecture notebook, but I'm just giving you lots of examples. Under what conditions can we add 2 arrays? What is the result of array addition under these conditions? So I will first show some results that work, followed by some that do not because they create a value error. There are some comments in these initial results to either explain what is going on or ask questions about what is going on. Feel free to edit these comments. These are the code comments you see here. Be sure to remark on these explanations or comments in the markdown cell following these code cells where you address the 2 questions above. So where I have the code comments or some questions, make sure that you're addressing all of that in your markdown cell when you're explaining the conditions under which 2 arrays can be added. Now, can we add an array to a constant? Apparently, yes. What about a different array to a constant? Yes. So constant 1, constant 2, we can add these 2 arrays to get something I'm calling an array sum. Can I add an array to itself? Absolutely. You can add arrays of different shapes together if very specific shape characteristics align properly. What is it doing? What is the result, and how do they have to align properly? These are good things to figure out. So array 1 and array 2, right? Here's array 1, 1, 2, 3. Here's array 2, 1, 2, 3, except it's in a different shape. It's a 3x1. And if I add a one-dimensional to a two-dimensional array, under some circumstances, I can add them together. And if you look at the result, here it is. I think I've run too far. Here it is. The array 1 and array 2. I get 2, 3, 4, 3, 4, 5, 4, 5, 6. So you have to ask yourself, what just happened? So under what conditions could that work? Can I add array 1 to array 5? Yes, I can. Again, array 1 is a one-dimensional array, and array 5 is a three-dimensional array. It's 3 2x1 arrays. And yet, I was able to add it together. I was able to add array 1 to array 5. What about array 3 to array 5? That also worked. And what about array 2 to array 5? That did not. That produced a value error. The shape characteristics are not in good alignment. There's something about broadcast. They can't be broadcast together. And there's another error here when I try to add array 4 and array 5. I didn't try every combination. You might try some different combinations and see what happens when you try to do them. But you should answer for at least these ones here and say under what conditions, because certainly an array can be added to itself, but it can also be added to an array that's a completely different shape, as long as certain conditions are met. So you need to answer those here and then explain what the result is based on these experiments or some other experiments that you might run. Problem 1b. Below, we show how you can make use of the try and except commands to handle errors, like value errors. You can read more about these here in this tutorial on errors. I won't click the link in this video. We do this to demonstrate how it is possible for you to handle potential errors and give useful feedback to users that is perhaps more informative or relevant than a standard error message produced by the basic Python code you're running. This is particularly useful to incorporate inside of functions that allow for flexible types of inputs, where you might want to try various things to allow for outputs before you say that there is an error and you don't know how to work with these types of outputs. So that's something to consider. And so as we're trying to build your level of sophistication of Python coding here, what you have to do is change the feedback given to the user if there is an error in the code cells below. What feedback should you give? How should you change it? Well, try seeing what the actual value error is that is returned and make sense of it. For example, see the errors from the previous part of the problem. You should give a value, you should print something that's not can't sum those. You should change that to a generic piece of information that's more useful, that knows that there's a value error and that there's something wrong with the shape, and it should be related to how you answered this problem, to give the user some information about why you couldn't add that. Now, there is, of course, these operands could not be broadcast together with these shapes. Why? Why can't those shapes be broadcast together? What's the issue? Try to think of that and just answer it generically. I'm not saying wherever there's a problem, you want a specific print command. You want something that generically tells the user, here's the type of issue you've encountered with the value error. So that is the type of information that's more informative for the user. Instead of somebody saying, I don't know what it means that they can't be broadcast together, explain to them why they can't be broadcast together. Why addition of that type's not defined. Or maybe what the conditions what conditions are necessary for them to be defined. So that's your objective here. You just need to change these print commands to something that is actually relevant related to this value error. Problem 2, array shapes and multiplication. You need to try running each of the following individual code cells and explain in the markdown cell that follows, 1, the conditions under which two arrays may be multiplied using either the asterisk or the np.multiply. Remember, this is the component-wise multiplication. And 2, what the output of the array multiplication is under these conditions. So you've seen some conditions under which this works. Like I know an array can always be multiplied to itself component-wise, but what about when they're of different shapes? So that seemed to work, but again, this was a 1D array, this was a 2D array, and look at in the output is something maybe unexpected. Can you explain what that output is? That's what you need to do, is explain why that output is what it is and what conditions are met for that multiplication to even be defined. You then need to rewrite each of these code cells, every single one of these code cells, with the try and except, just like what we saw here. And you need to give the user some relevant feedback about array multiplication in the case of a value error. So in this case, it's not sums, it's multiplications, and you need to explain under what conditions were violated that led to a value error, and maybe how the user might try to fix it by changing the shapes of the arrays. So your explanations, the first part of this problem, with the explanations about what you can do, go in this markdown cell, and then you redo all the code in these just using try and except commands as you saw here. Manipulating array shapes. Now you've already seen the reshape in a lecture notebook. This reshape function, and I provide a link again to it here so you can look at the reshape and how it works. The reshape function is of use here. So we use the markdown cell below. You are to use the markdown cell below in 3A for your 3A answers here to explain what is going on in this code cell. Look at some of the comments in the code below for inspiration about what to discuss. And you may even want to add your own code comments. Put your answers here, your explanation of what's going on. There's a ravel and a flatten function. I provide the links here. I won't click them. You need to run these code cells below. There's 3 of them. You need to do a bit of digging and reading into the documentation I'm linking to here between ravel and flatten, and answer what is going on. Explain in the markdown cell following these code cells, right here, and include a description of some scenarios where you may want to use ravel over flatten and vice versa, because they will appear very similar, but they are different. Combining arrays using hstack, which is a horizontal stacking. I did try and accept everywhere here. You need to run these code cells below. You need to change the print command if you have a value error to something that's more informative than can't do that. Maybe let the user know more about what went wrong. To figure that out, actually look at the value errors. Make your own code cells where you just do something that produces an error and that produces a value error. And, excuse me, I'm just pressing the wrong keys here on my. There we go. And then think about how you would give the user some useful feedback if there was a value error. Interpret what is happening in the markdown cells following these code cells when you try to do a horizontal stack, an hstack of various arrays. And notice sometimes I'm doing this .t, which is a transpose. That shows up in a few other code cells as well. VStack is like a vertical stacking of arrays. You're supposed to run the code cells. You're basically repeating the same thing you did above with 4A, except now with VStack instead of hstack. So provide some better feedback if there's an error and interpret what is happening in the markdown cell following these. Problem 5, run these code cells below, edit and add some useful code comments in there, and interpret what is happening in the markdown cell that follows. And then finally, problem 6, what is good in life? Asking your own questions. Being your own boss, investigating the things that are interesting to you. There are so many things that we are not going to cover. You should play around with some other methods available to you in NumPy for manipulating arrays. Again, check out the documentation on array manipulation. Think about what you want to do. Maybe you want to append an array like we did to lists. Pick at least 3 manipulations we have not investigated above and write some code showing how to utilize them along with a brief interpretation of results in a markdown cell. How deeply you investigate is up to you, but you need to do at least 3 manipulations. That's the minimum. Do at least 3, have the code, write some code comments, write a brief interpretation of results in a markdown cell. Here's some suggestions. Compare tile and repeat. Compare flip to the list method, reverse. The split methods are also interesting. There are lots of interesting things to do in NumPy to manipulate arrays. So do some, and when you look into documentation, you're going to find examples. So you can look at those examples as starting points for your own examples. So that's it. That's the entire assignment notebook. There's plenty of room for exploration and experimentation on your own. Thanks for listening, and we'll be moving on to Module 3.